Hey class, this is lesson 4.7, congruence and overlapping triangles. You will learn how to identify congruent overlapping triangles and to prove two triangles congruent using other congruent triangles. Go ahead and pause if you want, and we'll do the vocab. All right, problem number 1. What is the common side in triangle WXZ and triangle XWY? Figure that out. I think we're going to redraw these two triangles. Here's WXY, and here is XWZ. And if we look closely, you'll notice that they both have this side. So side WX is the common side. All right, problem 2, using common parts. So we're going to try and prove that angle T is congruent to angle U. And sometimes there's some parts on the triangle that are common to both, and if that's true, we can use the reflexive property to help us prove it. So we're going to start with the givens. RT is congruent to US. Actually, let's analyze this quickly to see what we have going on here. We have a couple right triangles that look like this when we separate them out. And so we see that these two angles are congruent, the two right angles, since all right angles are congruent. And we're also given that RT is congruent to WS, or US, that is. And since they both share side RS, we can say that those two are congruent by using the reflexive property. And then we can use the hypotenuse leg theorem to prove this. So our other given is that angle URS and angle TSR are right angles. It's given. And we have angle URS then is congruent to angle TSR. And that's because all right angles are congruent. And by the reflexive property, we have segment RS is congruent to segment RS. And so by the hypotenuse leg theorem, we get triangle TSR is congruent triangle URS. And since those two triangles are congruent, the corresponding parts are congruent. So angle T is congruent to angle U. And that's because the corresponding parts of congruent triangles are congruent. If you want to use the converse of the isosceles triangle theorem to prove side C is congruent to DE, first just show that angle BCD is congruent to angle ABC. And if you already showed that the two triangles are congruent, then you can use the corresponding parts. Congruent triangles are congruent. And if those two angles are congruent, then triangle CED is an isosceles triangle. So by the converse of the isosceles triangle theorem, CE would be congruent to DE. All right. Next thing we're going to show is we're going to use two pairs of triangles here to prove this. What I'm going to try to do is show that these two angles here are congruent, and if those are congruent, then we'll use the converse of the isosceles triangle theorem to show that those two legs there are congruent, which is what we're trying to prove, that side AS is congruent to segment LS. And to do that, I'm going to first show that these two triangles are congruent, and then I'm going to subtract those two congruent angles to show that these two are congruent. All right, so we'll first write down our givens and establish that these two triangles are congruent. So, and I'm going to do that using side angle side. So we have AR is congruent to LR. That's a given. PR is congruent to IR. That's given. And we also have an angle that they have, those two triangles have in common, so angle R is congruent to angle R by the reflexive property of congruence. And those three things together give us a triangle. ARP is congruent to triangle LRP, and that's by side angle side. And now that I know that those two triangles are congruent, I have that corresponding parts of those are also congruent, so I get from that segment RL is congruent to segment RA, and also angle RLP is congruent to angle RAI, and that's the corresponding parts. Congruent triangles are congruent. And from that we have angle RLA is congruent to angle RAL, and that's using the isosceles triangle theorem. And we also have that the measure of angle RLP is congruent to the measure of angle RAI, and that's just the definition of congruence. All right, and we're going to put some angles together now so that I can show. I'm going to subtract those two congruent angles from there to establish that this angle is congruent to that angle. And I'll put the steps in there. So I just use the angle addition postulate for that, and since we already know that angle RLA is congruent to angle RAL, I can combine these two statements. The measure of angle RLP plus the measure of angle PLA is equal to the measure of angle RAI plus the measure of angle RAL. And that's just substitution. And then if I subtract, since I have these two equal angles, these two measures are the same, I can subtract one of those from each side of the last equation, and I get the measure of angle PLA equals measure of angle IAL, and that's the subtraction property of equality, and that leads to the angle PLA being congruent to angle IAL. And that's just the definition of congruence. And finally, AS is congruent to LS by the converse of the isosceles triangle theorem. There's going to be a second part to this video.